My educational background started, I think, at Rice University. That's where I went as an undergrad in Houston, Texas. And Rice was where I went in thinking I wanted to do biochemistry. But at Rice, I really saw the incredible majesty of the molecular nature of life. How the genes specified the proteins, which became the molecules that drove all the different processes in the cell. At Rice, I saw my first class in my main technique, which is called X-ray crystallography. So my main technique is that we take our biological molecules we're interested in, and we grow crystals of them, like you would grow sugar crystals in maple syrup left open to dry a little bit. When you have a crystal of the molecule, you have hundreds of thousands of copies of the molecule, all oriented like in military precision. You put this crystal in front of an X-ray beam. When the X-rays shine on the crystal, they scatter. And then from the pattern spacing of the light they scatter, you can figure out the atomic structure of the molecule. So it's a way to see something that's submicroscopic. There's no microscope that can see these things. So this is my main technique. I saw this in college that I thought I wanted to be a marine biologist or some other kind of biologist. And they made me take this class in biophysics or in X-ray crystallography for my major. And I thought it was going to be horrible. I thought I was going to fail it. And I saved it until my second semester of my senior year because I was pretty sure I was going to flunk it and I didn't want the bad grade to go in my transcript for graduate schools. But I was sitting in this class and all of a sudden it was like the skies parted and light came down and it was the most intellectually satisfying thing I'd ever seen in my life. That if you could use this technique to figure out the very fold in nature of the molecules that drive life, everything you need to know about biology is written in that beautiful symmetric pattern. And it's just, how smart are you? Can you figure it out? Can you read in that molecular structure and the way the threads are all intertwined how the protein works and how life is achieved at the molecular level? I also learned in this class, by learning how to solve the molecular structures of things, that life at that molecular level is beautiful. So if you look at snow, it's lovely. It's a white carpet on the branches, on the fences, on the ground. But if you look at snowflakes, it's a very different thing. Each one has a beautiful symmetry about it, and they're all different. Proteins are just like that. Every protein has its own beautiful fold and their own beautiful symmetry, and they're incredible little things to look like. Each one looks like a different snowflake, but they all come together in concert to make life happen on the molecular level. And so in university was where I saw how these things could be. So I thought, this is what I want to do. This is the most interesting thing I've ever seen in my entire life. I want to be the molecular artist that understands these structures and how they work. And then the question is, once you have this biochemistry degree, what do you do with it? Do you become a doctor or a researcher? Do you get an MD, a medical degree, or a PhD, which is a research degree? And I weighed them back and forth. I thought, well, the thing about an MD, I mean, you can cure disease, very nice, very satisfying, you can help people. But I thought there was a good chance I'd be seeing the same colds and flu all the time. Where with PhD, which is a degree in research, I thought there was a good chance I'd be seeing something new all the time. Things that people hadn't discovered before. So I went to graduate school to get a PhD. And in graduate school, it's a degree in, not in receiving information from the teacher and giving it back on a test, but a degree in how to discover something new all by yourself. A problem in research or in life or in science that no one has ever figured out before, and you are going to do it. You are going to produce information which will wind up in somebody else's textbook one day. So I went off to graduate school. I chose that route because I wanted to do something new. I wanted to think. And in graduate school, I was introduced into infectious diseases. So the project that gave me my PhD and how I became Dr. Saphire instead of Mrs. Saphire was the HIV vaccine problem. Why has HIV evolved so much? Why can't we make a vaccine? It's because HIV is not one single virus. It's a swarm of all different viruses. And the challenge has been trying to find a vaccine that would mimic enough of all of them to give you an immune response that would be effective. So we had antibodies. These are molecules that your immune system makes to fight a virus. These came from a person that had been infected with HIV for 10 years but never gotten sick. So why not? Is there something special about his antibodies? Well, we had one that could inactivate the whole swarm of viruses. So there's something special about this molecule. So with my skill set of understanding how things work on the molecular level, can I understand how this antibody defeats HIV and how we can make a vaccine to make more like it. And so that was my degree. And then I set up my own lab to do more viruses and more things like that.